This is question number 7 on Schoology, and we're going to start off with a power that's actually not on the star chart. It's the 0 power. And if you want to do a little bit of background just to kind of see what's going on, like if we have 2 to the first power and 2 to the second power, that's 2, and then 4. 2 to the third power would be 2 times 2 times another 2, which would be 8. And what we're doing here is we are dividing by 2 to go backwards. So if I divide one more time by 2, 2 divided by 2 would give me a 1. So if I continue that pattern going backwards, the 0 power would be 1. This works with any number that we do whenever you do the power. Anything to the 0 power is 1. And that's our rule. Okay? Anything to the 0 power is 1. So here we do have a 0 power. We are still going to follow the multiplication and division rules, which means remember that we have to watch out for those coefficients and follow our rules. And then the exponents we have to look at, are we adding them together or are we crossing them off, which is like subtracting. So we have a ginormous fraction and there's a whole lot of stuff going on in there. We have positive and negative exponents. So the very first thing I'm going to do is find out who has what power. So we have this negative 5. Negative 5 goes with just the x. The 7 goes with just the y, and the 0 goes with just the z. And the same thing on the bottom row. This negative 2 does not go with the 6 and the x. It only goes with the one thing next to it, which is the x. And so by identifying who has the powers, that might make things a little bit easier. So now I'm going to start to write these down. The 4 is happy on top. And remember that it's just a 4. We can put an exponent on it if we want, that invisible 1, but we don't have to. And so that 4 is going to be on top. Now this x to the negative 5 right now is unhappy. It's sad. It's sad being on the top. So what we're going to do is we're going to rewrite it on the bottom. And I'm going to go ahead and instead of just writing x to the 5th, I'm going to go ahead and expand it. Okay, now notice when I wrote it on the bottom, the negative went away because it's happy now that it's on the bottom. So I'm going to expand it. So I'm going to erase that exponent, and I'm going to go ahead and do the power, the cloning. 2, 3, 4, 5. All right, now we have our y to the 7th power. Y to the 7th power is happy where it is. That 7 exponent is very happy. So I'm going to go ahead and put that up on the top. So I'm going to go ahead and write it 1, 2, 3, 4, 5, 6, 7. And then at the end we have z to the 0 power. So z to the 0 power, another way that you can think about this is we have our rule, but it also is cloning 0 times. So it's almost like the power of invisibility because there aren't any zeros. We're going to write z 0 times. So we don't write any z's at all. And then we're going to go down to our bottom row. And then we have our 6. And so we're going to write a 6 on the bottom. And I just put that out front so that my numbers, my coefficients would be together. And then next to that we have x to the negative 2. X to the negative 2 is unhappy. It's unhappy being on the bottom. Why is it unhappy? Because that exponent is negative. So that negative exponent means that we need to move it. And if we look at our rule for our negative exponents, you can see that it was negative and it was unhappy on top. So now we moved it to the bottom and it's a positive. Now it's happy. So let's go back to the question that we're on. And just to make things a little bit easier, I'm going to go ahead and rewrite these negative exponents that were on the bottom to a positive on the top. And again, I'm not just going to write it as a positive, I'm going to go ahead and clone it. So x squared, x to the power of 2 would look like this. And then we're going to have our y to the negative 3. Y to the negative 3 is also unhappy. How do we know it's unhappy? Because we have that negative exponent again. And there was one up here that we moved. And when we see that negative exponent, we want to move it so that it becomes happy. So this one means instead of writing it on the bottom, I would write y to the third on top. And again, we're going to go ahead and clone it. So the power of 3 looks like 1, 2, 3. I ran out of space, so I'm going to extend my line. There we go. And then this last piece says that we want z to the 8th power. And z to the 8th power is currently on the bottom in the denominator of the fraction, and it's happy being down there. So we're going to keep it down there, and we're just going to write 1, 2, 3, 4, 5, 6, 7, 8 z's on the bottom where they're happy. And now, based on the rules that we had before with our coefficients, we actually do what it says. So right here we have a 4 over a 6. And again, you can simplify this. If you are not confident in your simplifying skills, you can type that into Desmos, and it will do that for you. And that simplifies to 2/3. So I'm going to change that to 2/3 because both of those can be divided by 2. And if I look at my answer, it is a ginormous fraction. This right here is your fraction bar, right here. And it's a little bit spread out, but this is the best that I could get it. So we have a 2 on top, right here. So that 2 is going to go on top, and it's a positive. And then the 3 is going to go on bottom, and there's the 3. So you can click it and pop it in, or you can drag and drop. Now the next thing says y up here. So let's talk about why the x's are actually on the bottom. The x's are on the bottom because when we simplify this, there's more on the bottom. So the leftovers are on the bottom. And typically when we write our answer, we're going to write it with a positive exponent. So if we have an x on top and an x on bottom, those cross off. And we get to do another set that crosses off. So we have 1, 2, 3 that are left on bottom. So it's going to be x to the 3rd power on bottom because that's where the leftovers are. Those x's are on bottom. So we have x to the 3rd power that we're going to click and pop in or drag and drop. Our y's are on the top because if you look at our expanding, all of those y's are on the top together. And so what we do is we put them together and we just count them. We had 1, 2, 3, 4, 5, 6, 7 on the top the first time, and then we had 3 more that moved on to the top. So together we had the 7 and the 3, that makes 10. So we have y to the 10th power that we're going to pop on the top. Y to the 10th. Make sure that I saw a 10 right here also. Be careful. Y to the 10th. Okay. And then we have our z terms. And again, our y's were on top. Our z's are on bottom. So we're going to put the answer on bottom and we're just going to count them. And we didn't do anything to those. 1, 2, 3, 4, 5, 6, 7, 8. So all 8 of those z's stay together on the bottom like that. And you would again click it and pop it in or drag it and drop it. So we had a bunch of rules. We had the rule where we added our exponents, and then we had the rule where we subtracted our exponents. Okay? And here we also have the conversation about our coefficients. We're not adding or subtracting those. We actually have to do what it says. If they're in parentheses next to each other, that's multiply. If one is on top of the other, that's a divide, and you can simplify that on Desmos. Here is your final answer to number 7.